Thank you. So today we're going to do kind of like a pretty much what you expect, a quick overview of Cloud Foundry. We'll use the IBM Cloud as our platform. So if you want to follow along, that'll be great. So I'm Max. I am the CTO for Cloud Foundry at IBM. But I also spend quite a bit of time working on the code. Cloud Foundry is open source. And there's also Nima here, who is an engineer also in Cloud Foundry. And he'll do part of the presentation. But at the beginning, if you are following along, he'll help you if you get stuck or if you have questions. Because we don't have a lot of time to stop to cover as much as we can. But obviously, if you have a question, just raise your hand, and then we'll see if we can help you. So pretty much we'll just go straight. So there's only 3 slides. We're just going to go straight to the presentation, I guess, which is the, oops, let me see what's going on. Yeah, which is to use Cloud Foundry. So Cloud Foundry is a platform as a service. So what it does is it helps you run application, manage them, and so on. Obviously, you need an instance of that platform to be able to do anything. We're going to use the IBM Cloud. So the first thing to do is to get an account. I think there's cards here to help you, and log in. Since I'm part of IBM, it's going to redirect me to do a 2-factor authentication so that I can log in with my corporate ID, and then we'll get started. So, give me a second. Of course, we're doing live presentations, live everything, so sometimes things don't work. I don't expect it not to work, but things can happen. Okay, so when you log into the IBM Cloud, you get a dashboard, which sort of displays all your apps, all your resources. The IBM Cloud, I have to kind of give you an overview quickly, because the Cloud Foundry piece is just one part of a bigger whole. Allows you to do many different things. So obviously Cloud Foundry apps, which is what we're going to spend time on. But you can also do functions. You can do Internet of Things. You can do blockchain. And also you can set up, for instance, a Kubernetes cluster if you're going to use that to build sort of large services and so on. So it's pretty comprehensive. You can even spin up a server, and that server will be dedicated for you. For instance, like a physical server, and you get access to it. So it's a very comprehensive, I guess, platform for all cloud things. And one of those things is Cloud Foundry apps. So we'll get started on that. One of the things I want to show you is that in all of these, there is a catalog. So you can actually browse your catalog to also have a different view of what you're doing. So for instance, here you can see that there is like compute, storage, network, and so on. We'll get back to it. But the point here is that it's a very comprehensive solution. Now, to get started by what we want to do here, which is an app, and sort of connect it with maybe a service, is to say, okay, well, when you get to your dashboard, you're going to create something. So how do you create that thing? Well, you go to your catalog. So let's go to the catalog and find, for instance, Cloud Foundry applications. And we'll see that there are different kinds of applications that you can get started with. This is, again, to help you get going fast. Once you are past this point, you'll be able to also go straight to bypass a lot of these introductory things. But I think it's important to, especially for people viewing, if it's the first time you're doing Cloud Foundry or using the IBM Cloud, that you understand that a lot of this is provided for you so that you can get started easily. So Nima and I program a lot in Go. Cloud Foundry, a lot of it is built in Go. So we're just going to do a Go app, and then we'll show you how you can essentially follow the template that's provided to get going and then make some changes and so on. If you don't know Go, Go is a programming language that is kind of well suited for cloud, and it's kind of the hot new things these days, so that also helps. You can see here it tells you that you're going to be charged something. Obviously, if you're part of this class, you get an account that gives you some amount of free usage, but otherwise you really do have to pay. So I'll give it, like, for instance, a name. So I'll say lunch and learn SF. Hopefully that's not taken. You pick your domain, where it's going to be located, obviously for latency reasons. And it chooses an organization for you and a space. I'll tell you what those are after, but you can accept the defaults. So once you create your app on the UI, it actually gives you kind of like a tutorial of what you can do next. So this is part of why, if you're following along, you can actually go at your own pace a little bit. But also at some point, if you want to get back to it or you want to have more people train, have them follow along also. There are a few things that you need to have. Obviously, the IBM account, because you have to be able to log in here. You need the Cloud Foundry CLI, and the link here will allow you to download it. You need Git and, of course, Go. Go gets packaged as a executable. Most platforms, you download it, you install it, and then you get a Go command line that you can start using. For Git, you should know that already. And then for the CF CLI, it's a CF command line. So one of the things, so a couple things that are happening here and that we're going to be doing. First is that you can see that it's saying it's starting the application. And eventually, when it's started, you'll be able to visit the app. So here it is. So we'll say open in a new URL. And you can see it says Hello World. So this is your basic, yeah. Yeah. You can use a series of boilerplates, yeah. So Ruby, Java, Python, pretty much any language. So one of the things that Cloud Foundry is very good at is supporting a wide variety of languages. Pretty much every language, that's being in use right now, you can do in Cloud Foundry. Now the boilerplate is to get you going. So you can see once you start, you now have a Lunch and Learn SF, right, at mybluemix.net. But the application is just a simple Hello World, right? So how do we change it to put another application, for instance, the application that you're building? So in this case, I'm just going to go get one application that already exists, and then we'll make some changes to it, right? So that's the next step. So first thing we need to do is to set up our Go environment. So it's pretty much, kind of what you expect. I already have that created, so let's go into work. You need to export your Go path. This is a way for Go to know where code are going to be added. And then you need to also add a bin directory, so that tells you the path and also your Go path bin. So everything that you are going to build is going to be somewhere in your bin, so it adds them there. The next step is to create your source directory. I already did that, so I'm just going to skip this part. Go code gets added to a source directory. So we're just going to go to that source directory, and then we're going to go get that code. Right? And what that's going to do is it's going to go to the internet, get to github.com IBM Bluemix, get started Go, and download that simple app. If you had your own GitHub Go app, you would just go get that code, and you would specify github.com/your name/your project or /your organization/your project. So it actually goes and gets the code. I already did all this before, but it's, we'll change things quickly. Once you now have your code, you can get into that directory. So you can see it's pretty much like, what you would expect. Let's get to it. And it's a Git directory, so that's why you see in my Z shell it's saying it's a Git directory. That doesn't matter too much, but eventually if you want to start making changes and pushing your code and so on, that's where it would be good to have it come from a Git repo. So let's make some changes to this code. So first thing I'll do is I'll open it. I'll use I guess an editor called Sublime, which allows me to make some changes to edit very quickly. One thing, so part of these boilerplate applications is to help you run your things locally, but also remotely. So you can have like this seamless experience where your local code, you can test things and then eventually push it. And the reason you have dev, for instance, as a space is that we can have mini spaces. You can have a test, a prod, and then a dev, but also your local environment. So we're just going to build it and run it locally. So you make and then you go run the main code. That's how you do some, I guess you get projects and Go running. So Go run, and then wherever your main code is in your Go. And what that does is it runs the project that we just made changes to locally, and it's running at 8080. So let's just go to localhost 8080. And you can see it's a simple, okay, sorry about that. I need to make one change. So that's the trick of running code before. So we have the project. It's a simple kind of project that says, you say, what's your name? It says hello. And then, of course, you can say, hey, what's your name? You say Nima. Hi, Nima. And hello world, very simple. But you can see it doesn't have any memory. So it doesn't remember anything because it's not connected to any database. So every time you make a request to that application, it's just going to return it. So that's the first step of the application. Obviously, one thing you should be asking yourself is how do we connect it to a database so that we can save the data? That's going to be the next thing. But before we do this, we are running this code locally. So we need to push it to somehow run on the cloud because currently our cloud application is this, right? So we want it to be this new code that we just did. And just so you know, like, there's no magic. This is the code, right? And there's some point in there it says hello. So, right? So we can say, for instance, maybe we can do fancy and say so we're just gonna say hello Max from right. I'll put a space here. Alright, so we'll just restart the app. And if we go to the command line at the hello and we say max, it should say. So you can see the app is running locally. All right, so how do we push it? So in the step by step, right, it kind of tells you what you want to do. So first thing you want to do is there is a manifest for every application. This is kind of how you tell Cloud Foundry how that application is going to be run. So for instance, you can specify the amount of memory initially that you want the application. You can specify build pack. You do have to specify a name, and that name has to match your app. So that's one important thing. There's also a random root, which will change the root that you have. So if you have a name that is not this common name, you can change that too. And you can specify a lot more information. But the important thing is that there is one piece of information that is important. It's the name. Pretty much everything else can be defaulted. And there's a lot more things that you can do. For instance, you can ask it to start 3 instances of the app initially versus 1. But let's accept the default and then push it, and then we'll make some changes. So I'm going to go to my code and look at the manifest. And you can see here I had previous version of what I had here. We'll change the random root to be false. And we'll accept the 128 meg because it's a simple app. It's not doing much. And then you can see it says the build pack. Now, again, as I said, a lot of this is defaulted for you, even the build pack, because the CF command line will discover what application you're running. Now, obviously, if your application uses multiple different, platform, like say Python, Go, and so on, then it may be confused. So that's where you have to specify it. So most of the time, you can actually accept the default. So let's run it remotely. So I'm just going to start a new terminal. Oh, I guess I don't like this. Okay, so we can see the changes I made to the manifest. Right, that's good. And we now need to use the CF command line. Let me decrease the transparency on this thing so that you guys can see this a little bit better. Where was it? Window. Transparency. So as I mentioned at the beginning, you need to have the CF command line. So you say CF, and it tells you kind of, the different commands that you can have for an installation. But obviously, the CF needs to know where it's going to talk to, because you could use that same CF command line to talk to Pivotal's Cloud Foundry, or your own local Cloud Foundry, your enterprise Cloud Foundry, or the IBM Cloud. So you need to specify an API. So if you say CF API, it tells you what the current API is, but you can also specify a different API. So I'm not going to change the API, but I want to show you that depending on where you deployed, the API changes. So in this case, if you remember at the beginning, I accepted the US South because that's the closest one to where we are in the US West. So you can just accept this URL. But if you were in, say, in Europe, you might pick the Frankfurt one or the UK one. So you specify that, you say CF API, and then the name, I guess your complete URL. Now it's connected to it in terms of it knows which Cloud Foundry it needs to talk to. Then you say CF login, and at this point, it will forget that you logged in. So I logged in before coming here, but obviously, it took some time, so it requires me to log in again. So I will do that. And once you're logged in, you can now issue commands, because now you're connected to a particular instance of Cloud Foundry. So if you remember at the beginning, I showed you I had a dashboard with all my apps. I can say CF apps, and it's going to show me the same thing. So this is the new app we just created, right? And it's started already because we use the default, and you can see it's running just one instance. So what we want to do is take the code that we have with the small change we made and push it to the cloud. And this is the beauty of CF. So if you've used other platforms, it's a lot more complicated than what we're just going to show you right now. So to take that code and move it to the cloud, it takes really just one command, just CF push, and that's it. So with that command, which takes a little bit of time because it's going to package your application, it's going to, of course, discover what your application is, it's going to use the manifest, package it, create kind of something called a droplet, and then push it to the cloud, and then ask the environment to start that application, and so on. So it's taking some time, but all of this is happening for you in the background, and that's all you need to do. So you make a new change to your app, CF push again, and that's it. And then I'll show you how we can scale it. We'll just do CF scale. You can scale up and down. You can change memories, and so on. So for me, and since it's going to take a little bit of time to push it, I want to kind of give you an idea of why Cloud Foundry exists and kind of the value of it compared to other platforms. A lot of the container platforms that you hear about, they seem exciting because people are talking about it. But try to use it, and you'll see, right? The experience that you have in Cloud Foundry is really the experience that you have in a really well-designed operating system for the cloud. You have a command line. You have very clear notions, services, apps, routes, scale, and so on, and just use it to do exactly what you want. So it's very much focused on trying to make the cloud disappear and just allow you to focus on your code. Everything else is just, outside of the things that you need to care about. So your cognitive burden is really reduced. At least that's the goal in Cloud Foundry. Okay? Everything else out there doesn't do it as simple as this. Now, of course, to add, to make the platform richer, we added more commands. So, for instance, nowadays there's, over 60 commands for Cloud Foundry. But to get started, you really just need to know 2 or 3 commands. That's it. So I think the point here I'm making is that Cloud Foundry is designed to get you started quickly, to make it super easy for you, and allow you to also add feature to your application, such as scaling, routing, if you have multiple applications that you need to connect together, and so on. And you'll see even debugging is relatively easy as well. So one of the things that Nima is going to do when I'm done showing you how to connect it to a service is we're going to introduce a bug, and then we're going to show you how you debug it and how you discover, and so on. So now, in theory, now the application should be running. You can see it's telling us here that it's using about 10.6 meg of disk space because it's a tiny application, and then 5.8 meg of memory, and virtually no CPU. And it's running. So what we should be able to do is if we go here and we refresh this page, then we should be able to see our hello world pretty much like we did before. And I say max, and you can see the change that we made is also there. So that's still part of the idea. If you wanted to make more changes, you make more changes, push it, and you'll be done. So the next thing that we want to do is to obviously go from where we are now, which is an application that's not connected to a database because we don't have a database, it's just in memory, so it's disappearing, to connecting it to a database so that way you can actually remember this, because every application needs some kind of a storage, and you don't want the storage to be in the same node as the application. You want to separate them so that you can have more failure, resiliency, and so on, right? So if you follow along, one of the things that they tell you here is to look into the database and try to add connection to the Cloud and NoSQL database, for instance. And it's a good one because it has, it's free, which is always great. And you can actually do quite a bit with it because Cloud, which actually is, I think part of the team is based here in this building. It's a IBM acquired that company, and they provide essentially a NoSQL JSON database on the cloud for you, and you can scale it to whatever you want. So the free version should get us going. So how do we find it? I'm going to open a new page with the catalog, and we're going to just look at what's available, right? So again, always the idea is that you go to the catalog to find what you need, pick either a free version or paid version, instantiate it, use it, and then go back to the command line to do other things that you want to do that are quicker. And once you experience this, you can actually bypass a lot of this UI, right? But the UI is there to help you, make it easy for you. So if you go here and you say, okay, well, what's in data and analytics, you can see that there is a really great range of database. Not trying to brag, but we invented the database, meaning IBM. I used to work at the lab where the database was invented, meaning SQL and so on. So you should expect we are very rich in terms of the kind of database that we provide. Some of it tends to be very specific to the kind of thing that you need. So obviously this app, people are not going to die, right? If something happens to this app, and money, you probably won't lose any money at this point. So you can use a free version of something like a cloud and database, which will allow you to scale to some level. But if you needed more, like Informix, if you needed DB2 and so on, you could get it. So let's find the Cloud and NoSQL DB. You can see there's a light version, as I mentioned, that's free. So you pick it, but the experience you're going to see here is very much the experience you will get for pretty much all of the different databases. Typically what happens is you instantiate the service, once that service is instantiated, you need to connect it to your application, and there needs to be some exchange of parameters, typically some security credentials that need to exchange, so that your application can talk to your database and vice versa, right? So how do we do this? You just create the instance, so we're just going to create it. We accepted the same default just because, you know, there's no point in trying to create it in a different location. Now, once it's there, there's many things you could do. Like, for instance, you could launch it and start querying that database and so on. But obviously, the first step for us is to create a connection. So let's connect that database instance that we just did to our application, which is the Launch and Learn SF, right? So we can say, okay, well, we got this thing, and you know, pretty much made that connection. But because obviously, I mean, I guess some languages might allow you to be more dynamic, but in most cases where you're connecting a service to an application, you do have to restage the app. What that does is it allows that connection to be live, right? So we say restage, and it's going to connect the two together. It takes a little bit of time because the restaging is essentially restarting the application. But as it's doing this, one of the things that we want to do is to get some credentials. So we need the credentials so that now in our application, now they're going to be connected, but there needs to be the security, I guess, exchange or verification. So we say create a new credential. You can accept the default, or you could change it to whatever you want. Once you do this, it will now give you a credential that you can view. I actually happen to work on this code that creates the credentials. And one of the things that we've typically done for databases, the credential is just a JSON, is to provide you with username, password, the host port, and then a URL that sort of combines a username and password so that you can use those kind of connection URL when you're connecting from your app to your database. So we're going to do this. The app was designed to allow you to easily connect to a database by just having, I think, cloudent URL, where you can specify that URL, and then now your local environment as well as your remote environment will be able to connect. So if you want to test this, the remote is being restaged, but the local environment, if we restart it and we go locally, then we should be able to see that we have a database, hopefully. So let's do that. So we run it again. And we go here. So this is running locally, and we say max. And you can see now the app just shows the content of the database. So you can see that the data is being kept. And if we say hello Nima, and it's there. And I think this app also has a API visitors to be able to see that endpoint, and you can see this is the content of the database. Now this is all local, but it's connecting to the remote database, right? So what we want to see is whether or not our remote instance is also running. So if we refresh, and you can see the same content is there too. So this is the remote, so we can say hello SF. And then if we go to the API, the visitors, then we should be able to see the same thing, right? So we can see all the content of our database. So this is as easy as it is, right? I mean, this is an application that's going. So let's assume this app, and Nima and I thought about doing this, but maybe would be in trouble. What if we made the app be a Bitcoin miner? So something that, you know, instead of saying hi to you, it randomly tried to give you a Bitcoin. Some people are laughing. If you don't understand what Bitcoin is, they're worth $12,000, $20,000. It's something outrageous. It's just a number, but they are rare, and people are willing to pay money for it. So if that was the case, and let's say this app actually did that, chances are one of you would be trying to connect to this, and then maybe you would have tweeted about it, and maybe within 30 minutes, enough people would be trying to get to it that it would have crashed. So let's say it was some kind of like popular application like this. then how would you deal with that? Well, in most cases, you'd have to scale your app, right? So this is how easy it is to scale an application on the IBM Cloud and in Cloud Foundry, is you say CF scale. So let's say it's being, I guess people are trying to connect to it. You go here, you pick your name. CF scale what? Your name of your app. What do you want? You want like a number of instances. So let's say -I equals to 4 instances, and then maybe the memory would be a better thing so that we can tell people very quickly if they get their Bitcoin or not. So let's double the memory, right? And that's it. And of course, it will take a little bit of time. Let's say yes, and within maybe like 2 or 3 minutes, you now would have 4 instances of your application, each starting with more memory, so that you would be able to respond to 4 requests at exactly the same time, right? Obviously, something like an application that takes some time to produce, the requests would have to be piling up, so you could scale it to 16 if you wanted to. Now, obviously, the more you scale, the more memory you use, the more you would pay. So we're happy for you to scale to however you want, but you keep that in mind, just like any other cloud, right? So now if we say CF apps, we should see that this app has 4. And then if we somehow was not actually giving Bitcoin to people, we're just faking it, we could just go back down to 1 because people discovered that and nobody's doing it. So you scale down to 1 pretty easily like this. Another thing I want to mention is that a lot of these sort of command line things you can actually automate. There's tons of different plugins for Cloud Foundry to help make this experience even easier. Even the scaling up and down is automatable, where there is a service that you can create an instance of and say, hey, I want to start scaling automatically my application up to 16 instances when I get X number of requests or I reach a certain threshold, right? So the experience, again, is super friendly for you as a developer. It's making it pretty much safe for you to do anything you want. So with that, let me stop and see if you have any question. Otherwise, we're going to pass it to Nima, who's going to essentially introduce a bug to the app and then help show you how you can actually debug and what kind of features are available. So let's see. Yeah.
So there's some downtime associated with scaling. Is there a workaround perhaps that needs to be constantly updated?
All right. There is a blue-green deploy that's being added to Cloud Foundry in the command line. You'll have a blue-green push where when you push your app, before it scales up, you'll have, I guess, before you push a new version of the app, you'll get the old version there. And then until the new version is running, you'll be okay. But there's ways that you can do this even without the automation, because remember I mentioned space. So if we say CF spaces, we have one space right now, which is a dev space, but you can create new space. So you say create space, and then you create like a test, and then you can create a prod space. So your apps that are essentially in production would be in the prod space, and that you could even like control it and make sure that only a few people have access to it and can actually push code there. And then the dev space for all your developers, and then the test space maybe for testing environments. So that way you can actually do these kind of, not necessarily blue-green deploys, but clearly test environments, having applications that are there for you to try before you actually push it in production. Here we're just pushing straight to dev because we're living dangerously. Any other questions?
Just to add to what Max said, staging doesn't always cause downtime. It depends on what you want to do. For example, if you choose only to increase the number of instances, your previous instance, the instance that you already have running, is going to stay. And then the new instances just get added, right? The reason we had the downtime here was because we bumped the memory for the app, which basically meant the container that was running the app had to now acquire more resources from the underlying VM, and that required the restart. So the runtime for Cloud Foundry is working on other solutions. That the older solution that Max mentioned is the blue-green. So you have like some apps running in parallel with one another. So you start taking one down slowly and then bringing another one back up. But there are other solutions that the runtime is putting in place so that you don't see the downtime. And you can roll
Any other questions? Okay, so Nima is going to show us how to debug. So I'm going to take my camera so I can take pictures of it.
All right, thank you.
So sweaty.
Yeah,
He's actually a bit sick.
Yeah, so I feel a little bit under the weather, so sorry for my voice, but overall it's exciting to be here. I'm a core developer of Cloud Foundry, and obviously I get super excited when it comes to talk about Cloud Foundry or anything Cloud Foundry related. So before I get into the details of how you debug the app, I want to mention a couple of points. The one thing that is important with pushing apps to Cloud Foundry is that similar to Kubernetes or other platforms, when you push an app, it actually puts that app into a container and runs the container into a VM. Now, when you scale your instances, which basically means that you increase the number of containers that now have your code deployed on, what Cloud Foundry and a lot of these other cloud platforms do is that they distribute your instances, your containers, across VMs. And that gives you a certain level of guarantee that if one instance goes down, the others are going to stay up and running. And so hopefully you're going to get better resiliency with the system that you have. Now, before I show you how you debug, I want you to have a better understanding of what happens under the hood for Cloud Foundry when we actually do a CF push. So when we do a CF push, this is like a high-level architecture of Cloud Foundry, like all the different pieces and components. And the component that I'm primarily a developer of is the Diego subsystem, which in itself is like a distributed system. So when you do a CF push, the first thing that happens is that your CLI, or the cloud command line interface, starts communicating with the cloud controller, which is the front end to the entire Cloud Foundry system. You put information about the code that your app has, the name of the app, the resources that the app requires, and what happens is that Cloud Foundry says, okay, let me go figure out how I can deploy your app. So then what happens is that it talks to a component called the stager. The stager takes your code, tars it, uploads it, and then untars it, looks inside of it in order to determine what type of code it is. As Max said, you can mention the build pack, which is basically the runtime that your app requires. You can choose it to be Python, Go, or whatever. But if you don't specify a build pack, Cloud Foundry is smart enough to look into your code and figure out, oh, I see Python code, so it's probably a Python application. Or I see Go code, so it's potentially a Go application. So what happens then is that when it determines the runtime, it then puts the runtime and the code and packages them all together into one tar file, which is called the droplet. And the droplet is basically the core of all Cloud Foundry needs in its runtime component to run your app. So then it starts talking to Diego, and this is my land basically. So the cloud controller talks to Diego and says, hey, I have this app, it requires these many instances, it requires these resources, now go deploy it for me. And then Diego starts looking into all the machines that are available and decides, okay, so we need this much memory, and we have these many machines, and we need these many instances. How can I figure out the placement of your application so that I distribute it across good enough number of machines so that if one of them goes down, your app doesn't go down completely, but at the same time is optimized enough so that if other people come with other apps, I can still find a way to also place their resources. So it becomes a complex scheduling problem too, a bin packing problem if you're familiar with the computer science there. So then when it figures that out, it then starts deploying it. It actually pulls the droplet into a VM, into the machine that runs it, and then untars it, and then calls the binary runtime that is already identified to run and execute the application. And then through the route emitter, the route emitter sits somewhere here. Through the route emitter, it communicates back with the router. Oh, there it is, route emitter. Communicates with the router, and then makes your app available to the outside world. So now, from that point on, your app can start receiving traffic and basically serving requests. One thing that's important, and this is something that was discussed during the Cloud Foundry Summit in Basel, is that more than 50% of customers of Cloud Foundry run their deployments of Cloud Foundry in a multi-cloud environment. And that's a very important point. The thing with Cloud Foundry and Kubernetes and the new platform as a service systems is that you do not necessarily bound to one infrastructure. You do not need to go with Amazon. You do not need to go with Google. You do not need to go with IBM, but you can actually spread across. So one thing that Cloud Foundry does, and the 50% of the customers do, is that they actually spread across all this. So I'm sure that with soft layer, we have potentially customers that run half of their services on soft layer and possibly some of the other services in another cloud provider. And that's the beauty that you can get with Cloud Foundry. So yeah, that's a very high-level overview of how this all happens. There's a lot of technical to finding and figuring out how to place the apps and how to make them available and run and how to do health checking. So the primary thing that is important for me as an app developer is that when I push an app, I want to make sure that my app is up and running and it's healthy, right? So once you look at the app that we just pushed, you see that when it reports on the status of the app, it says the state of the app is running, right? So essentially, the app is healthy, and you can potentially ping the endpoint, which I think is this one, and it's running, right? Now, if I stop the app, actually, let's just try this. If I stop the app, what happens is that it turns down the container. Cloud Foundry turns down the container that runs the app, and your app becomes basically unavailable from that point on, right? So there's no route to the app. The application is not there. Now, what if I'm basically deploying my application. I'm trying to figure out, how best make the application work. And during the process, I actually introduce a bug in the system. So let's have a look at that. Let's say, we go to the main.go file, and in the main, I happen to have a division by 0 issue somewhere. So if I have I equal to 0, and then if I have println 10 divided by I, hopefully that'll give us a division by 0. So now I go and do a CF push of the same app. Oh, not this one. So let's see what happens this time. As a developer, my hope is that when I do a push, it actually becomes successful. By the way, during the process of pushing an app, if you look carefully, you see that it actually shows you information about the staging process. Basically, taking the app, making a tar off of it, uploading it, and then see, this is creating the container, staging of the app, identifying where the build pack is, putting everything into a droplet, and then making it available to Diego for it to actually start running it. So, yeah, as a developer, my hope is that once I do a CF push, it basically comes back with a successful deployment. But the reality is that that's not always the case. You happen to have bugs in your code, you push your code, and things start falling apart, and then you need to figure out where things actually failed. So, what is that? Yeah, that's what I'm going to do, but I'm waiting for the thing to fail first. If it actually runs fast enough. Cool, so staging is done. Now it's trying to upload and run the app, and we'll see whether it actually comes back successful. All right, so you see at this point, 0 of the 1 instances that we pushed is running, and it's retrying, right? It says, yeah, I'm trying, it's still not running, it's starting, but it's not running. So if I look at the app now, if I look at the logs for the app, and, okay, so if I want to see what recently happened with the app, I can ask for the recent logs. And then it goes and fetches all the latest information about the code that we pushed. And if you look carefully, we see, oops, integer divided by 0, right? So this is very similar to the output that you would get if you run your app locally. But if there is any failure, let's say the failure is more complicated than this. Like, for example, your credentials for your application, you forgot to upload it to the cloud. So when your app tries to start, it cannot communicate to the database, or any other sort of problem. Then you get to see all that information here. Now, let me just do a tmux session so that I can do a quick split of these So if I do fix the issue, basically get rid of these two lines, and do another CF push, then this time the hope is that things are going to work fine. But one thing that we can do is that beside just looking at what's happening, we can look at the logs of the app in a real time. So we can say, show me what's happening with launch and learn SF. Not just pulling for the latest ones, but basically for whatever that's happening in real time. So now it's actually taking down the old app, which is the one with the wrong code, tears it apart, and then it's downloading the new app, figuring out the build pack, launching and installing the build pack, and bringing the app to a running state. And if you notice, when Dr. Max ran on the local output, we were seeing the etc. You're going to get the same information when you do CF logs from the app that you have. So the output is basically getting streamed over from the remote instance to your desktop. And that way, it actually makes it a lot easier for you to see what's going on in the app. So this is the essence of it. As you said, debugging is actually very simple and quite trivial. It's no different from having to deal with your app locally, especially because you get a lot of these standard error and standard outputs right through the logs that happen in the app. So with all of that, Cloud Foundry has come a long way trying to make it as simple as possible for the app developers to basically get their apps up and running. So these are for the staging, because when this container is actually deleting things, you see that now it says container became healthy. So if we go back here and refresh, then the app is back up and running and connected to the database. So, and to wrap it up, I think Cloud Foundry has come a long way, making it easy for developers to push their applications. If you haven't done so, I would encourage you to go to IBM Bluemix Cloud Foundry and try it. It's actually a lot simpler than you would think. With that, I hand it back.
Yeah, let's take some questions. See if you have any questions, any other comments. Yes?
Two questions.
Yeah.
One is for build packs.
Yeah.
The second is also well, one is for build packs. You were saying that build packs can figure out the languages.
No, the CF command line. Yeah. So CF is a command line, right? It's a utility. That discovers the build pack for you, unless you specified it in your manifest. So,
yes, so the question is, how does it detect the version of the language?
It doesn't necessarily detect the version of the language. It will pick the last one, the most recent one. But that's why you have the manifest, because in the manifest you can specify, let's say you wanted to go with Go 1.7. So then you pick up the build pack with Go 1.7 because you have some reason. Obviously, you want to be at the latest version because there are security issues with all these things that you want to be at the latest. But you can run code with previous version. I mean, that's one of the beauty, right? It's to allow you to pretty much do what you want, but the defaults make sense so that you can use the default and feel comfortable that, not only they make sense, but they're also good for you, right?
But do you know, is it possible if I don't specify it, and I'm using a weird version, let's say for Python or for Go, that's not necessarily compatible, is there a technology right now that can detect it automatically?
No, it won't detect it for you. You'll have to specify it in your manifest.
Thank you. That's one thing I need to know. The second thing is when you do CF push, the staging process, how is it different when I'm doing CF push using a Docker image?
You want to take this?
Sure. So the whole practice is a little bit different, because when Cloud Foundry differentiates between build pack apps and Docker apps. Mm-hmm. And with the Docker apps, it assumes that you already have a Docker registry somewhere, and you're pointing your application to that Docker registry. So at that point, all that involves is that it goes, finds the image that you've uploaded to the Docker registry, And running the image is no different from running a container. Like basically the Docker runtime is run C, which is the same runtime that Cloud Foundry uses for its containers.
Yeah.
But what happens is that when you specify a Docker image, it goes fetches that Docker image and then brings it down and runs the Docker container on top of the Diego infrastructure. When you specify a build pack is only code and the runtime for it. It doesn't have the run C part to it. So what it does is that it goes and grabs the build pack, provisions a container for you, which is a run C Cloud Foundry container. It's called Garden container, and then deploys your code on that Garden container and runs a Garden container. So the difference is that when you run a Docker app, you run a Docker container. When you run a build pack app, you run a Garden container.
Yeah. And there, I guess the way to also think of it is that when you're doing your CF push, it will do all the work that you would have had done to set up what your image would be and so on, because it's discovering for you. Right? And Cloud Foundry is so if you don't like that aspect of it, you can actually provide your own build pack if you wanted to, or you can even provide your own discovery of the build pack too if you want. So, any other questions? Yeah.
Yeah. So I see that all the URLs have the .mybluemix.net.
Right.
Is there any way to?
Yeah, you can change that. You can change that.
Is that inside
That's the default, but you can. There is a step-by-step process you can follow to essentially change your wood for specific apps that you want to, like your own domain.
Okay.
Yeah.
So if you've got more than one instance, obviously there's some load balancing going on
Yep.
to route to those instances. Can you tweak that in any way, or is it just round robin?
You want to take this?
Sure. So basically what happens is that when the requests come to the apps, the requests go to the router, and then the router decides which app it sends it to. I think right now the strategy that is in there is round robin, but you can also tweak it in the router so that you prefer, like if you do a blue-green deploy, you can basically do like a 60 to 40% split, so that 60% goes to your old deployment or your new deployment and 40% to the old deployment, something like that. Yes.
Any other question? We were round robbing it.
So let's say you do a CF push and
Yeah.
you discover that there's an error with your application. Is there any way to revert back to the previous version of your app? Or do you have to push?
I mean, like, well, typically, let's say when you do CF push, your undo directory where changes work, right?
Yeah.
And hopefully you had some Git branch,
Yeah.
and you did that, and you find that there's a problem, you want to debug it locally, you can just revert to the previous branch and then push again.
Okay.
Right?
Yeah.
So it works with your development environment. Use Git to do what Git is great
Yeah.
at, which is versioning things. Right? I mean, that's one way. There's all the other ways, especially if you use the plugin deploy that's provided. Certainly also, I think, when you're ready for a production environment, you definitely want to have a different space. You definitely want to have a different instance of your application. And in there, you want to make sure that you are pulling the branch that is sort of tested and vetted, right, so that you can feel comfortable. So, any other questions? Comments? Cool. So this is obviously the first version, Cloud Foundry 101. I know when I was talking to Maya and the rest of the team, they mentioned maybe after this it makes sense to do a 201, where we can go into a little bit more detail, like maybe, for instance, doing some of those blue-green deploy, maybe going down into how you can set up your own instance of Cloud Foundry, in your environment, which would take a little bit of time, but is interesting to do. And then maybe some of the more advanced features. So for instance, Cloud Foundry has ways for you to set up networks between applications so that you get fast connection between them. So if you're doing like a microservice kind of deployment where each microservice is an app, and you can get that. We can look at more interesting services than what we had here. So there are many different things. So when you provide your feedback, it'd be great if you can tell the team here what it is that you would be looking for, and then
obviously they will be collecting the feedback, and then we'll try to come back and maybe have something more interesting. Yeah, so there is a feedback form. Please make sure to fill it in. And thank you, Nima. Be safe.